Alright, let's get this started. Alright, this is the protocol presentation for the Network Systems class by me, Jacob Tyler. The protocol I decided to speak about is IP, Internet Protocol. I believe it's one of the most important protocols, basically the foundation of how hosts communicate on networks and on the Internet, be it between subnets or directly to websites. It's the protocol that does that work. So let's go ahead and hop into this. IP as a protocol. It's a primary protocol by which data is sent between hosts on the Internet, and like I said, even through subnets too. So if a host exists on a separate subnet and one needs to communicate with another host on a different subnet, they use a router to communicate with each other using the protocol IP. They do this by assigning IP addresses to the hosts. Now, the IP addresses are assigned by DHCP on the network, and those can be either dynamically assigned through a lease, where the DHCP server actually sends out the IP address and allows the host to lease that IP address for a certain amount of time. And then after that amount of time is spent, it renews that address. They can also be set up as reservations, so if a router or a host needs the same IP address every time when it's rebooted or whenever DHCP hands out addresses, if you needed to keep the same address, you can set up a reservation that reserves that address for only that host, using its MAC address for an identification purpose. Like I said, they're also used to communicate between subnets, which is very useful in large networks, such as at a school or a business, where you want to segregate your network up into different sections to cut down overhead in sections of the network. Subnets are great to set up that way. And, of course, IP is going to be used to communicate between those hosts and those separate subnets. Okay, there's two versions of IP version 4 and IP version 6. IP version 4 is the most common one that you'll find in the workforce, and it is used it has 4 octets. And the IPv6 uses a hexadecimal format. IPv6 was actually invented because we ran out of addresses to use on the Internet for hosts to communicate on the Internet with IPv4. We used so many of them that we used up the amount of address space that we had. IPv6 actually, I forget the actual statistics, but I believe it quadruples the amount of space that is used it actually makes it smaller so that you can have more IP addresses. We'll go into too much detail with IPv6 since it's not as common, but it is still being used and it will be implemented permanently in this future. There are different classes of IP addresses. There's Class A, Class B, Class C, Class D, and Class E. Class A addresses, as you can see on the presentation, I won't read out the numbers, but you can have 16 million hosts on 127 networks. Class B network, you can have 65,000 hosts on 16,000 different networks. Class C addresses, you can have 254 hosts on up to 2 million networks. So really those first 3 there, those are the ones that you deal with more directly in a networking job. You'll deal with D and E as well, but ABC is what you're going to use to subnet your networks out. So Class A would be used if you wanted to have a lot of hosts on a few networks. So if you had a large company that you had lots of hosts that needed to be communicating, but maybe you had 5 branch offices or something like that, that would be a good network for that. If you had a medium range company that had not as many hosts as 16 million, say the 65,000 as the Class B, you could use that. It gives many more networks, so if you had, say, 5 branch offices every city, in the United States, that might be a better solution for you. It all depends on size of hosts and the size and the amount of networks that are needed. Class C, it can be used in those kind of environments. Normally it's in a small office environment, and home networks, private networks are normally set up in a Class C network, but you can configure them in either Class B or A, but there's really no reason to, because that's too many addresses for the few amount of hosts that you'll have in a private network. Class D IP addresses are reserved for multicast groups, so they send out a multicast broadcast address on the network that goes to all of the devices on the network. Class E is reserved for future use. They're using it for research and development at the time being. With that, I'm sure that in IPv6 there's the same idea going on. They need to research and develop ways to make IP addresses last for a longer amount of time and be more efficient, because the internet's just going to grow and it's going to need to be faster and it's going to need to be more efficient. And the better IP address schemes we have, the more that's going to be fulfilled. Okay, so back to what I was saying at the first slide, receiving an IP address. DHCP is what assigns the IP addresses from a network range that's actually specified by the network engineer. So the network engineer could say, back here on this slide where we had class A, B, and C, say we had a 192.0.1.1 through, well, that address range. Well, we could actually go 192.0.1.0, and that address range, any number from 1 to 254, could be used as an address to be handed out by DHCP if you set that as a network range in DHCP. So when a host comes online and requests an IP address, DHCP server looks at the network range you've specified. It finds that it's a Class C network range, and it assigns an IP address accordingly. Like I said, also, IP reservations can be configured. This can be configured normally on a server or a router, something that's going to need to retain the same IP address so that hosts know where to point to. Say their default gateway, which would be the router, where they could route packets, IP packets, to the internet or to host in a separate subnet. The reservations are used. Actually, I work at a Votech, and we use reservations on a lot of our host computers because we have certain policies that we want to implement in our Mac lab, where we set up them with IP reservations. So they retain the same address every time they boot up so that they know where to point. Well, the server knows where to point to give those policies. IP addresses can also be statically assigned or manually assigned to hosts. So whenever you're configuring, or network engineers configuring a host, they can set up IP addressing to be automatic, which is through DHCP, or they can also set up them to be statically assigned. And when you statically assign an IP, you give it an IP address, a subnet mask, a default gateway, and a DNS server or servers. This gives a specified IP address so that you specify the range it's in, you specify the subnet, you specify what default gateway it needs to point to, and the DNS server is what resolves requests whenever they request a website. They resolve that website name into an IP address and give the website to the host. IP routing. This is an interesting part. Hosts use IP addresses to send and receive data on a network. We, of course, know that. But they send directly to each other if they're on the same subnet. So, say host A wants to talk to host B, and they're on the same subnet. They send the packet straight to each other. If host A and host B exist on two separate networks, say a Class A and a Class C network, two separate subnets, they can route through a router their default gateway and get those IP packets from host A to host B. Just as if on the outside it would look just like they're sending it directly to each other. But when you look down at the network level, you see that they're actually sending to the default gateway first. So my conclusion is IP is really the backbone protocol of the internet. We use it every day. Even if we don't think about it, we're using it. We use it every day at the online classroom for OSUIT. We use it at our jobs. We use it when we listen to music, download games, whatever we do, we're using IP. It allows communication between hosts. It allows communication between hosts on a network and a business between host and server. A server could be a host too in that definition, but say a host is a PC talking to a server. They use IP to communicate. They also use it if you're reaching out to the internet to a server out there, which is what you're reaching out to on a DNS server, to resolve a name to an IP address. They are able to be divided up. So subnetting is subdividing your network up. It helps with overhead, like I said. The segmentation helps the network engineer to be able to look at the network and say, oh, this is how it's set up, and this is where these IP addresses need to go, and this is where they exist. So I know where to ping and where I'm expected to get communication, where these hosts are expected to have IP addresses. So that is it. Thank you very much.